welcome. My name is Forrest Longman, and I'm the current president of City Club. The mission of City Club is to inform, connect, and engage our community to strengthen the civic health of our region. We emphasize civil conversation and listening to others. Our August 25th program will be a forum with the candidates for the Port of Bellingham. The Port of Bellingham is charged with promoting economic development throughout the county. The port is governed by 3 commissioners, and 2 seats are on this year's ballots. The contenders in District 1 are incumbent Michael Shepard and his challenger John Huntley. Vying for District 2 will be the top 2 primary election finishers among incumbent Ken Bell, Austin Chapin, and Kelly Krieger. On September 22nd, our program will concentrate on the 4 county council elections. Their candidates for the open seat in District 1 will be the top 2 vote getters among Eddie Uri, Jeremiah Ramsey, and Kaylee Galloway. In District 2, incumbent Tom Donovan and Kelly O'Connor face off. And in District 3, the top 2 primary winners among incumbent Tyler Bird, Fred Rinnard, Kathy Seibel, and Rebecca Lewis will be on our virtual stage. And at the large county council, candidates will be the top 2 primary finishers among incumbent Barry Buchanan, Bob Burr, Kamal Bachu, and Misty Flowers. As always, I'd like to thank all the volunteers who make our programs possible. I'd also like to thank KMRE Radio Board member Robert Clark, who's producing today's program, and BTV 10, who will be broadcasting it to their viewers. I'd also like to thank our business sponsors for their support. They are Larson Gross, Lummy Commercial Company, Danny Neal of the Molyat Group, the Opportunity Council, Pacific Continental Realty, Unity Care Northwest, Village Books, Western Washington University, Whatcom Community College, the Whatcom Community Foundation, and Bruce and Claudia Dizend. Finally, I'd like to turn things over to Chris Roselli. Chris is the Director of Community Relations at Western and a member of the City Club Program Committee. He'll introduce our speaker and moderate today's program. Chris?
Well, thank you so much, Forrest, for the introduction. Hi, everyone. Well, as far as we know, Earth is the only inhabitable planet. I think we've all been curious, though, since we were young and perhaps wondered, what if there is life up there among the stars? And fortunately for us, scientists and students from Western Washington University's Mars Lab are on both NASA's Curiosity rover team and the recently launched Perseverance rover team, where they are trying to untangle the history of water on Mars. And today we get an opportunity to hear from Kristiana Lapo, who is a researcher in Western's Mars Lab, and she will shed some light on what we know about Mars, the challenges of space research, and ultimately, whether we'll ever know if there is life beyond the planet Earth. But before I introduce Kristiana, here is a little video to give you a small taste of the Mars Lab and their work with the Perseverance rover.
I have 2 students who are working on lab work supporting Mastcam-Z. Mastcam-Z is 2 cameras. Those are the eyes of the rover. 2 other students are working on mapping the area where the whole rover is going to land, called Jezreel Crater.
One of the instrument team that I am a part of, that instrument is on the rover, getting ready to go.
It's kind of surreal, just like what we do on a day-to-day basis.
We'll learn new things about Mars, which helps us learn about Earth, and maybe find some signs for life.
I'm really excited to be able to take the work that I'm doing and share it with the public and help bring in a new generation of scientists who see the world differently.
Are we alone in the universe? And if we find life on Mars, then that opens up the possibility that life is abundant in the universe.
To be a Western student and to get to be involved with hundreds of scientists from around the globe, working with them in close coordination, I don't know if there's any greater satisfaction as a student.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
That is so cool. So, Kristiana Lapo, she is a Mars enthusiast, a scientist from the Western Spectroscopy Lab, and is a lifelong Washingtonian. She received her BS in geology from Pacific Lutheran University in 2014 and her master's in science and geology from Western in 2021. Congratulations, Kristiana. She's also her current research focuses on how light interacts with surfaces as a way to determine chemical compositions. It's a methodology called spectroscopy, and that's used to study the surface of Mars. She also has a background in glaciers, geologic mapping, and climate history. And as a part of her work at Western, she runs the Western Martians Instagram account, which if you're on Instagram, I highly recommend that you follow. It is quite fun. And she enjoys creating content that is fun and accessible for a wide range of audiences, and particularly enjoys outreach, work with primary school aged children. So Kristiana, welcome to City Club. Thank you so much for sharing your knowledge and time with us. We really appreciate you having you here. And of course, before I hand the reins to you, I would like to remind our guests to use the Q&A function to submit any questions that you have for Kristiana, and we hope to get to as many as we can later on in the program. So Kristiana, take it away.
Thanks so much for that introduction, Chris. I am so excited to be here and to talk with you all about the work that we do at Western and how it relates to perseverance and the search for life. Okay, so I'm going to just give you a little bit of background on what perseverance is, what the goals of that mission are, how we're searching for life, and how Western kind of ties into all of this. So when we first started getting imagery back from Mars, this is the type of image that we were getting. You know, it's fairly grainy. We're looking at the entire planet. We don't have a lot of detail, but we can see a few things. We can see that there are dark regions and there are light regions, and we can see that there's something going on at the North Pole here. It looks like it's maybe a brighter region. So we can glean some information from this, but we don't have our cameras and our telescopes have come a long way since then. And with those, that improvement in cameras and telescopes, we've gotten much more detailed information about the surface of Mars. And so in this more recent image of satellite images, we can see that there's dark regions, there's light regions, there's a really bright polar region, but we also have a lot more detail. We can see these like giant gashes, we can see craters, we can see all sorts of textures and colors. So we've come a really long ways. In addition to having those telescopes and our telescope images and satellites that have more advanced camera technology on board, we have multiple rovers on the surface of Mars. NASA has sent 5 missions that include rovers. So all of NASA's missions are shown here that have successfully landed on the surface of Mars, and the ones that are underlined in white are the locations of rover missions. So the very first rover mission was called Pathfinder, and this carried a little teeny tiny rover called Sojourner. It's about the size of a dog. Opportunity and Spirit were our next generation. These were twin rovers. They were sent in the same year and landed in the same year. They both landed in 2004. And none of those 3 rovers so far are still functioning, but we also have Curiosity, which launched in 2012 and is still functional, and Perseverance, which is our newest rover that landed in 2021, February of this year. And I just also wanted to point out, this is the location of the rover Zhurong. This is China's rover. This is the first rover that is on the surface of Mars that wasn't put there by NASA. So that's a really cool feat. So I wanted to point out the location of that rover as well. So just like our cameras and our telescopes have grown up to get us better imagery, our rovers have grown up over time as well. So Sojourner, down in the front there, was a teeny tiny rover. It was about 1 foot tall. Spirit and Opportunity, they're a little bit bigger. They're a little more advanced. These are about the size of a golf cart. And then Curiosity and Perseverance are Not completely identical. This is a model of Curiosity that's shown here. Perseverance is slightly longer and has some other minor differences, but both of these are much larger rovers than all previous rovers. They're more like car size, like a Jeep. So we're definitely moving up in size. Perseverance has a few differences specifically from Curiosity. Several of them are just kind of structural things like adding a crossbeam for stability. The turret, which is basically the hand on the end of the arm for Perseverance, is stronger so it can hold heavier instruments. Perseverance has 23 cameras on board. This is an increase from Curiosity's 17, which was a huge number of cameras in 2012 when it was launched, and we've even managed to top that with Perseverance. One of the most visible differences between Curiosity and Perseverance is the wheel design. So Curiosity's wheel, this is a picture of Curiosity's wheel in the top left here. The way that the chevron pattern in the tread, it kind of focused when we drove over sharp rocks, it kind of focused the pressure into particular locations, and it's caused the wheels to start having holes in them. And so in order to combat that, Perseverance's wheels have been completely redesigned. They're thicker to help prevent that same kind of breakage, and the tread pattern has also been changed to prevent that kind of focusing of force. The most exciting difference, I think, between Curiosity and Perseverance is that Perseverance has a sample caching system. This means that Perseverance can drill into a rock and pull out a tube of that rock and store it inside the rover. That cache, once it is full, will eventually be left behind. The rover will drop it on the ground and continue on its way. And NASA has a mission planned later on, sometime in the next 10 years probably, that will just purely be a retrieval mission. So they'll send a rover out to go find that sample cache, bring it back to a rocket, and bring it home to Earth. So we haven't started using that sample caching system, but it's just really exciting that that's on its way. Mastcam-Z is the instrument, like what was said in the video. Mastcam-Z is the instrument that a lot of Western folks are involved with. These are the scientific eyes of the rover. They're on the lower part of what looks like the head of the rover. And they're basically really fancy cameras. The makeup of these is that they are a CCD bonded with a Bayer filter. This is essentially the same technology that's in your phone that allows you to take color pictures, or a digital camera, or any sort of digital photographic device has generally a CCD with a Bayer filter. The part that makes Mastcam-Z different is that it has this filter wheel. And this filter wheel, in each filter, we're able to filter for really specific wavelengths of light that we want to look at that tell us information about what a material is made out of. And so each filter has specific wavelengths that it filters for, and we can eventually look at all of those wavelengths together as scientific data. The Western Washington group, this was before my time personally, but this is, there was several students who were able to help, they were able to go down and help with calibration of Mastcam-Z at Caltech. And so we have on the left in this photo are 2 graduate students who were able to help with that process. And then on the right are 2 undergraduate students. And in the middle is our fearless leader, Dr. Melissa Rice. And you can see behind them into the clean room where Mastcam-Z was calibrated. And this photo off to the left is just a slightly better image of what those cameras actually look like. These are the actual cameras that went to Mars on the rover. I don't work directly with the rovers, with the Mastcam-Z, but what I did is I took that image, all the data that was collected during that calibration, from that last slide, and I compared it to data that I collected in the lab. Our lab instruments were really confident in what they do. And so my job was to make sure that Mastcam-Z was seeing what we thought it would see. And I do that with this instrument that you can see in the foreground here. It's called a goniometer. So Perseverance with Mastcam-Z on board launched to Mars on July 30th in 2020, and it landed 7 months later in February of this year. So I'm going to walk you through that landing process a little bit because I think it's just fascinating. So the entire landing process takes 7 minutes, but the amount of time it takes for us to send a message to Mars is about 12 minutes. So this entire process that I'm going to walk you through has to be entirely automated. So the rover does all of this by itself. So we just say, start your descent processes, and then the rover does everything from there. There is a heat shield that as it enters the atmosphere, there's a heat shield on this vessel that is protecting the rover as it's entering. And once we get sort of through into the atmosphere, we need to slow way, way, way down. So the rover's going about 13,000 miles per hour. And just with the parachute, so it sends out a parachute, we can slow down to about 900 miles an hour. Perseverance used a new strengthened parachute compared to Curiosity. But a lot of folks noticed there were these interesting designs on the parachute and were intrigued by this. So this is a photo from the rover looking up into the parachute and the Martian sky in the background. And when folks broke this pattern down, people were able to figure out that it was binary code. And what it actually says in binary code is "dare mighty things." So once the rover is slowing down, so it's in that the parachute is out, it's in the process of slowing down, we start to drop that heat shield. Once we're into the atmosphere, we don't need that heat shield anymore. And so this is a photo of the heat shield being dropped. So this is a photo from the rover looking down at the heat shield moments after it's dropped. And then we also have the surface of Mars in the background here. The final stage of descent, we basically use a jetpack on the rover to slow it down and kind of steer it to where it needs to go. This jetpack is called the Sky Crane. And during this process, this final stage of landing, the rover is using radar to figure out how fast it's going, how high up it is, and to help with some maneuvering to land where it's supposed to land as well. So the rover, the jetpack then, as it gets closer to the ground, lowers the rover on cables towards the surface. This photo is from landing day. This is from the rover looking upwards at the Sky Crane, again with the Martian sky in the background. And by the time it's touching down on the surface, it has slowed down from 13,000 miles an hour to just 2 miles an hour. And that entire process took about 7 minutes. This is my favorite photo from landing day. It's from the Sky Crane looking down at the rover and the Martian surface. This is just moments before the rover actually touches the ground. So it has this sense of anticipation to it. And you can also see the sand and the dust that's streaming in the background from the Sky Crane holding the rover in place. And once that rover touches down, it's a big celebration. Everybody is excited. This means that we get to continue with the work that we've all been anticipating and preparing for years. So it's always a huge celebration when a rover lands successfully. This is the very first photo that came back from Perseverance. This was within a few minutes of landing. We got this photo. This photo they took it so quickly, they wanted to get this right away, this confirmation that we're actually on the surface safely. The lens cap is still on. And then within about 24 hours, we were able to get the lens caps off and take photos of, take a look at our first photo of Jezreel Crater, where Perseverance landed without our lens covers. Perseverance landed in a place called Jezreel Crater. Jezreel Crater is home to an ancient delta. Deltas are geologic features that are formed when running water that has lots of sediment kicked up in it flows into standing water like a lake or an ocean. And then as that the speed of the water slows down, all that sediment drops out and ends up forming features like deltas or alluvial fans. Some of the oldest rocks in Jezreel Crater, looking at this delta, are 3.6 billion years old. Mars is only 4.5 billion years old, so some of these rocks are almost as old as the planet itself. This is our first look with Perseverance and with the Mastcam-Z instrument at Jezreel Crater. This is at full zoom. Mastcam-Z has some zoom capabilities. So this is just from the landing site. And what we can see here is that we have, we're seeing exactly what we want to see if we're looking for a delta. We see these layers in the rock here, and we see more layers here. And eventually we'll be driving up to those and examining them in a lot more detail. And what we're actually looking for with Perseverance is signs of life. We're not looking for currently active life. We're looking for signs that there might have been life at one point in the past. One of the things that one of the first pieces of recorded life on Earth are fossilized bacterial mats called stromatolites. Something like that would be really super conclusive evidence of life, but we're not really even expecting something that conclusive. We might just be looking for certain substances that we know are made by living things, or patterns that are made by living things. This is like the bacterial equivalent when we're looking for patterns of life. It's the bacterial equivalent of like finding a footprint. So we don't have a physical fossil, but like maybe we can find something that says, hey, something used to be here. And then even if Perseverance with the instrumentation that is on board can't find evidence of life, that possibility of sample return is going to provide us with another level of another way to look at these rocks and determine if there was maybe once life here. If we can get these back and study with them the full suite of the instrumentation available to us on Earth, it's very, very possible that we could find something or learn something with those physical rocks that we wouldn't have been able to learn just through Perseverance. So if you'd like to follow Perseverance rover and find out what's going on with the rover, there's a couple handles there. And if you want to find out and keep some updates on the lab, on the Western lab, and see what we're doing, there's our Instagram handle there that you're welcome to check out. Thanks so much for having me.
Thank you very much, Kristiana. Okay, we've got quite a few questions for you, actually, which is really great. And we'll start with, so when will the rover's mission be accomplished, and how long does its battery last, or are there like small Martian gas stations there that it fills up at?
Yeah, that's a great question. So because Mars is so remote, even if we are able to answer our mission specific objectives, we just keep going. We've spent all that time to get the rover there. If the rover is still functional, we keep doing science. So the rover's mission is never really quite done. But as far as how long they can last, so our longest living rover was 15 years, and that was Opportunity. But Opportunity was solar powered. Both Curiosity and Perseverance are nuclear powered, and so they don't rely on sun and aren't hindered by dust, because Mars is a really dusty planet. But those power sources are expected to last for about 10 years.
Wow, okay. And you talked about data collection. What kind of data are we specifically collecting? Yeah,
great question. So there's a ton of various types of data that's being collected. I'm just going to talk about specifically the type of data that Western generally works with. This is also the type of data that I generally work with. So we collect, Mastcam-Z collects what are called spectra. And to kind of help explain to you what spectra are, I'm going to compare the instrument of a spectrometer, which is what I use in the lab, to our eyes. So depending on what wavelengths of light are reflected or absorbed, we see different colors in the visible wavelengths of light. So for example, something that's green absorbs pretty much all wavelengths except for green light, and that green light is reflected, and that's what goes into our eyes and tells us that we're seeing green. But we only see a very small portion of the spectrum. We see just between about 400 and 700 nanometers. So we don't see, our eyes don't do that, but our instruments on Mars actually show a lot more. They show more. So the Mastcam-Z sees what's inside of this blue box. So it sees more than we see. But our instruments at Western are what we can see within this yellow box. So kind of depending on what the instrument is, we can see more or less. And just to show you kind of what that data looks like. So this is what a spectra collected in the lab might look like. This is for this rock in this spot right here. And then this is what it would look like for Mastcam-Z, where each of these dots or boxes is one of the filters on the filter wheel. So we don't get quite as much information, but we're still getting enough to tell us a lot.
So you've mentioned Western's Mars Lab. How did it come to be, and how did you get chosen to be a part of the Perseverance rover team?
Yeah, so the position that Dr. Melissa Rice holds right now was actually made for her. She had interviewed for another position, but they just thought that she was really phenomenal and made the space for her. And so she has all of our NASA connections. She's on the Curiosity team. That's kind of where it all started, as for Western specifically. As far as how the students are chosen, I think we kind of, for the most part, self-select. Melissa's always interested to hear when students want to be involved, and loves that students want to be involved. I think those of us that keep showing up and doing the work that needs to be done to be able to do this kind of science are the folks that end up in the lab long term.
Sure. So when we're traversing this planet, are we going to leave anything on Mars, like a flag or some, an In-N-Out burger or something, just to sort of prove our presence there?
Great question. We're not leaving anything like a flag, but at this point, there is no plan to retrieve and return all of the rovers that have become non-functional on the surface. So all of our landers that are no longer functional and all of our rovers that are no longer functional are still there, and there's really no plan to bring them back. So in a way, the rovers themselves are kind of a monument to their own work.
Sure, that makes sense. And NASA, as we all know, if we've been watching the news lately, it's no longer the only American organization that is actually exploring space. We've got private citizens and their companies like Jeff Bezos and Elon Musk and others who are traversing the solar system. Do you think this is a good thing? And what should the government be doing to help support this new interest and investment in space travel?
Yeah, so there are... I think what was just in the news this week is actually that NASA is starting to contract with these private space companies. So I think it's like Elon Musk's company, SpaceX, is they've been developing reusable rocket technology for a few years now. And in the process of doing that, they've blown up a significant number of rockets. Right in that testing, they failed a lot, and to develop that kind of technology, you have to have the resources to fail. And I think NASA's budget is often for the things that for all of the things that NASA wants to do, that budget is very, very tight and has to be really carefully spent. And so we've never had the resources to spend, reusable rockets are going to change the space game, but we've never had the resources ourselves to spend that much money on blowing up rockets, if that makes sense. Right. So I think there are going to be positive things that come out of it. And I think that, everyone has their own personal opinions on whether or not that's a good thing. But I do see that, NASA's contracting with them because they are doing new and novel things.
Do you think that space travel will be more common for the general population in your lifetime, whether it's to the moon or the space station or Mars or elsewhere?
I think that in my lifetime, it will probably become more common for like the ultra rich to have little joyrides into space, like the recent launches that have happened. But I think that the resources required to have professionals on the ISS or something like that are so significant. I don't know that we'll reach a point where private citizens are going to be able to do, longer trips, especially like to the moon or to Mars. And I think the ISS is really closely guarded. I think I would be very shocked if that ever at any point got opened up to private citizens.
Okay. Well, sorry, Tim Douglas. Looks like you're not going to be able to go up to Mars anytime soon for a little spa weekend or anything. So, okay. So you've spoken to us lay people in a way that we can understand. Could you just humor us a little bit and speak to us, say, for 30 seconds in your scientific language so we can feel like a space scientist for a moment?
Okay. I'm going to just give you a real quick summary of one of the chapters of my thesis.
Perfect.
So nanohematite coated basalt sand has no diagnostic photometric features, basically because the band centers and depths don't change with the addition of the nanohematite coating. And the scattering patterns don't change at all for any sort of spectral metric. Nanohematite has known absorptions in 2 locations, one in the UV and one in the infrared. And one of those, the UV absorption, does show up in nanohematite coated basalt sand, but the infrared one is obscured by a absorption in the similar region inherent to basalt.
Well, all the more reason why we're leaving this up to scientists as smart as you. So thank you for that. So now what comes after Rover? Do you think we'll look for life on planets other than Mars, or do you think we'll stick with Mars for quite a while?
I think that it's going search or just any sort of like scientific endeavor on Mars, I think that's going to continue for a long time. But there were some proposals for funding through NASA that were approved, I think in the last year sometime. And there's 2 missions that are going to be going to Venus. And Venus is kind of another planet that has possible implications for having had past life at some point. But it also has a lot of complications of studying it. The surface, it's basically had a runaway greenhouse effect. And so the surface of Venus is so hot that every instrument we've sent has melted within a couple of hours on the surface. And so it comes with its own challenges, but there are some new, like really creative, cool missions that are going to Venus. And I think Venus could kind of be the next frontier for that.
Cool. So you talked about when the rover lands, it's entirely autonomous. It does it all itself. And so if I recall correctly, it took about 15 minutes for you to actually even know whether it did land. Mm-hmm. The whole world was watching. I'm sure you were watching somewhere. I mean, what did you do for those 15 minutes? Did you take a trip to the store? Did you just pace around the house? Did you jump rope in place? What did you do to pass that time?
Great question. So I actually worked last year during the time of the landing. I was working for a Montessori school in an upper elementary classroom. So I was working with 9 through 12-year-olds, and we were all online anyway, and they wanted to watch. So I watched with them. We were all online together, and they were just throwing me questions for that entire nerve-wracking time. And so I was just answering children's questions the entire time. And honestly, it was a great way to kind of diffuse the stress.
Yeah. How cool is that? So some would say that we should be spending these billions, perhaps, on humanity down here instead of in space. Why spend resources to go to Mars? What do you say to that when somebody asks you that question?
Yeah. So I think for a lot of folks, space is something that is intriguing and hopeful and just inspires a lot of curiosity. And so I do think that there's, some level of utility in exploring that. And I think any implications, if we found life on Mars, that has meaning for what we can apply to what we know about life on Earth. As far as what we should be spending our money on, I think, this is my personal opinion, this is not, NASA approved. I think that we can do both. NASA's budget is, compared to the entire US government discretionary spending budget, is very small. It's 0.5%. And there are, other parts of the budget that could give up NASA's entire budget and not even be impacted that much. So I think that there's a way that we can do both. I think it's possible. Yeah.
So what do you feel is the main obstacle that your lab has overcome to get to this point? I mean, I'm sure it's not swimmingly smooth every step of the way.
Yeah. I mean, so many other labs and workplaces and just people's lives, COVID has been a really big impact for us. And we usually have, the entire lab is really collaborative and supportive. And we usually have a common space where we gather and we help each other and discuss things and build community. And so not having that space has definitely been really, really difficult and isolating, but we have been working to kind of build that space in a more of an online forum. And for me personally, I actually did lose my job for COVID, and I was ultimately hired on by the lab. They were able to find funding to make sure that I was employed and could continue doing the work that I do. So there have been obstacles, but the lab itself has also provided a lot of support.
Yeah. So what is it that you've learned the most thus far working with the Perseverance rover?
Yeah, so as far as what's actually been learned from Perseverance rover so far, it's been a lot of planning. And so what the rover teams have learned is what questions they are going to answer, and maybe have started to come to some conclusions about where they might answer those questions. I mean, as far as this is very cheesy given the name of the rover, but everyone that was helping put this rover together, during COVID, people put their noses to the grindstone and they made it happen, and we made the launch window. So as cheesy as it is, just persevering, keeping going. It's yeah, right. It's cheesy, but.
Well, no, I think you make a good point. I think that for so many people, the rover brings an indescribable sense of hope that we as humankind can accomplish anything, right? And so How did you feel when you received the signal that the rover safely touched down?
I am not often a super emotional person, but I was like ready to cry with relief. Like, it never really quite, I knew it was always a possibility that it could like burn up on entry. There's always things that could go wrong. It could crash into the surface. But I think part of me, because NASA has such an amazing track record, we've, successfully landed 5 of 5 rovers, including Curiosity, who landed with the exact same landing system. On some level, I didn't really think it could happen, that it could crash and fail. But still, even feeling really very confident, I was very relieved when it touched the ground. And I know that particularly for like some other folks that I work with, or for like my parents, it came with this like whole lineage of watching space exploration. And so I think there's another level for folks who are in like Gen X or boomer generations, who've watched this progression through space, who remember watching the Apollo landings, who watched the Challenger blow up. There's a lot more emotion behind it. So it's been interesting talking to some of the older generation of folks that I interact with.
Certainly. So what's next for you and the Mars Lab at Western now that we are, we're tracking the Perseverance? What's on your docket looking ahead?
Yeah, so for me personally, I don't work directly with the Mastcam-Z images. My work has really been on kind of behind the scenes. I worked on the calibration. I validated the instrument. A part of my thesis was validating that instrument, but and the other work I do is more like it will help us interpret the data that we do get back. And so I'll keep continuing to do that kind of work. But we also have students who are directly working with the images that are coming back from Mastcam-Z, who will be analyzing them and interpreting them and manipulating them to see what information we can get out of them.
Right on. Well, thanks so much for chatting with me. Those are the questions that I and the rest of the committee had for you, but we've got quite a few questions that have come in using the question and answer function in Zoom. My fellow colleague here, Elijah, who's also on the committee for City Club here, has been capturing all of these different questions. So Elijah, why don't you take it away and throw some more questions at Kristiana. Thanks so much, Kristiana.
Thank you, Chris.
Thank you, Chris, and thank you so much, Kristiana, for being here. This has been incredibly fascinating. Let me kick it off right from the start of people wanting to know when that rover lands on Mars and all the dust is kicked up, as we saw in that photo. How do you make sure that these incredibly expensive equipment is all protected from that dust? And is there ever problems with dust settling on it, and how do you maintain it?
That is a fantastic question. I don't know the entire ins and outs of how all that works. But we've worked, when the rover was being built, it was built in a clean room. And everyone that worked on it had to wear these like bunny suits and hats and goggles and be completely covered up, gloves, booties. And so on the Earth side, we've worked really, really, really hard to ensure that we're not getting any sort of debris inside the rover. And I'm sure that there's some level of protection because the rover, the rover body, it does encapsulate most of the instrumentation. So there's some level of dust protection there. But the biggest issue we've had with dust in the past has been when it settles on solar panels. And since our current generation of rovers doesn't use solar panels, we've managed to kind of skirt around that issue with dust.
Thank you. That's really helpful. I noticed that too in those photos of everyone being all up in those, you call them bunny suits. And I was wondering then how did that compare with the Martian atmosphere? People are also wondering about whether those spectrometers are able to be searching for complex organic compounds. And more generally, we've been getting questions about what you can learn from that light. I know that's most of what you've been studying and most of what you've been talking with Chris, but I'm wondering if there's like specific tools that light spectra conveys to other departments.
Yeah, so I'm gonna just throw up that image again. So I wasn't sure exactly what imagery I was allowed to share and wasn't. So I don't have any actual mission spectra from Mars, just because I think some of it a lot of it still needs to be reviewed. A lot of it hasn't been published yet. So I don't have any of that data, but this is a spectra that was actually taken by Mastcam-Z. And so the information that we get from this is where the absorptions are. We call them absorptions. So basically this axis here is saying the higher up it is on this axis, there's more light reflected, and the lower down, there's less light reflected. And when we have dips like this, where there's less light reflected, these are called absorptions. And where those absorptions are generally correspond to like particular chemical makeup, where that compound is actually absorbing the energy that makes up that wavelength of light. And so, for example, this here, there's this area here that has lower reflectance. Those values are lower down. And my guess is that this is from an absorption that's actually centered over, it's at a lower wavelength. We can't quite see it in this data, but it's indicative of ferric iron. So it's just saying like that, that's the type of information. It's like this absorption likely correlates with this particular compound, or series of absorptions, if there's several in a row, might be relevant to a particular mineral. And organic compounds absolutely have their own spectral signatures. I think we're generally not on Mars. We're not even looking for something quite that specific or obvious. But a lot of different materials have their own signatures for what we look for in the shape of this returned data.
So right there, when you say we're not looking for something as specific or obvious, what kinds of things do you look for then indicate that you found previous life, if not organic compounds?
So one of the big things that has been focused on is making sure we can find water. And so anywhere we find evidence of water, we're looking for life. And in the case of Perseverance, that evidence of water is just in the fact that feature exists. But we also look for specific hydrated minerals, so minerals that have water within their chemical makeup, because that's where we actually expect a lot of the water that used to be on Mars is probably now bound up in rocks. So we're looking for rocks that contain these hydrated hydration bands. That's one of the things that I know that the Mastcam-Z team in particular is looking for.
That's the steps removed from that. It blows my mind. Let's talk about the rovers for a sec. Some people are wanting to know, Kathy Thomas is wanting to know if there's things written on them for people who in the future retrieve them, just like the parachute had the secret binary coding on it.
I don't have any pieces of these pulled up, but there are all sorts of little Easter eggs. One of the things that's on the rover, there's lots of art. One of the art pieces that's on the rover that I love, it's like a little rover family photo, like the like stick figure families that people put on the back of the car. It's basically that, but for the rovers. And there's all sorts of little things like that. That's the one that I can think of off the top of my head, but there are, especially in like the calibration targets, there's usually like a couple little Easter eggs like that hidden.
I love them finding space for that beauty and art in what must be such a complex and condensed system. speaking of how to get the rover there, some people were wondering about that parachute, if it's specifically constructed by NASA. Some people had shouted in the chat rumors about them using 9-foot long needles on specialized sewing machines to make it. Is there any truth to that you can tell us about?
I have no idea. It sounds like people in the chat might know more than I do about that. I don't know anything about 9-foot long or nine whatever. I don't know.
That's all right. I was just wondering.
Yeah, I'm not sure. I don't have any background on that. I apologize.
Yeah, no, that's all right. Maybe you could tell us a little bit about why you first got into this area of science and why this was the thing that drew you to the stars, quite literally.
Yeah, so I actually got into this kind of by accident. I started at Western doing a totally different project, doing glacial geology. And it just got to a point where it wasn't working for me and I needed to do something different, or I needed to leave. And I had taken a class with Melissa, our Dr. Melissa Rice. I had taken a class with her, and she was just someone that I kind of went and talked to and said, like, hey, like, I need advice. Like, I don't really know what to do. And she just was like, I'll work with you. Like, I've had, I've always had, like, who isn't fascinated by space? Like, we all love, like, there's something about it that just has a really big draw. And I've always had that kind of level of draw. I really enjoy space. I want to know more about it, but like, I hadn't thought about pursuing it professionally until Melissa kind of proposed that. And it turns out that it was exactly what I was looking for. And I really love this work. I love the science. I love the lab group. Yeah.
I love that, finding the right people to be able to do the job with. What's one of the most interesting things you've discovered doing this project and working with NASA?
Let's see. So my work was kind of twofold. I modeled some work I modeled a material that we expect to find on Mars, and then looked at what the spectra of that look like. And then I also did the validation of the Mastcam-Z. And the validation is like, it's exciting because it was good, but also it's exciting because it's not exciting because there was really not a lot there. But the modeling that I did was something that like hasn't been done before. And so anytime in science that you're doing something that no one else has done before, there's just a really cool level of excitement around it. And so I actually ended up getting kind of a null result. I didn't have a lot of information, but just doing something novel is really fun and exciting, and is a really fun learning experience.
I can't possibly fathom just how true that must be. The people that you're working with, which you've mentioned is so essential, and the people that NASA brings into it, have you been able to notice, I'm actually just going to read the question. Sorry, it's not that one. What strengths other nations and their scientists are bringing to this space exploration? And are there any cultural differences that you can see in their efforts that particularly are key and that allow us to unlock these mysteries better?
Yeah, that's a great question. We have, in the Mastcam-Z team, I think most folks are in the US or Canada, but we do have, I believe, some Dutch collaborators. I think that scientists are kind of a singular breed. Like, they're like others, they're meticulous, they're really careful, they're opinionated, I actually haven't, not that I have a huge sample size, but I haven't noticed a ton of like cultural differences across that. Like, science is kind of a universal language.
I love that. It's a universal language you're using to reach out to the stars. speaking of which, what kinds of things, especially when we are looking out broader from our own solar system, can you tell using particularly this kind of light spectrometry system from the telescopes we have here about what other atmospheres and what other systems might be suitable for life?
So I don't know to what extent spectroscopy is used as we're looking into like other solar systems. Like it's something that could be used and I just have no idea. My work doesn't really look outside of our solar system, so it's not something I'm super knowledgeable about. But it's how we get, at least in our solar system, it's how we get a lot of kind of basic like composition information about what's going on the surface of other planets.
I imagine you can't get too much without being able to send the rover there. Do you know about the background of other students in the Western program? And if so, is there any kind of data about them you could tell us? I know one person's wanting to know if any of them started off at Whatcom Community College. And I personally am just interested in knowing about this team.
Yeah, I'm trying to think. I know we've had a couple of folks transfer in, but I'm not entirely sure where they started. I don't think they started at Whatcom specifically, but I do think that one of them started at a community college. We're also an interesting lab because we kind of straddle two departments. So Melissa is co-assigned to both the physics and the geology department. And so we have this interesting mix of physicists who like know all the physics about like why the spectroscopy works and the mechanics of different materials, but don't necessarily know the geology, and then students who know the geology without necessarily the same physical background. As far as our students are the undergraduates, I'd say the undergraduates come from both geology and physics. Physics doesn't have a graduate program, so we're all the graduate students are geology, and the graduate students really come from all over because we're coming from universities besides anywhere in Washington. So there are some who come from. We have one from Texas my year and another one from California, and I'm from Washington. So the graduate students are a little bit more varied.
I love that, y'all coming together from across the state and the region. I just want to remind anyone watching that you can put questions into the Q&A feature on the Zoom, as well as in the chat. I wanted to loop back to something that Chris mentioned earlier about working with other private businesses on space exploration and what they're able to bring to the table that NASA's not. I'm wondering if you're able to tell us just a little bit more on what NASA is able to bring to the table that private businesses aren't, and what it means to be able to have that publicly funded space exploration.
Yeah, so I think that one of the things that NASA is able to do that that like a private organization isn't is like NASA's budget, like I said, is compared to like the entire US budget is very, very small, and it's very limited. But the projects that it does do, it gives the appropriate resources to. And so like a mission to Venus, I think, is out of the reach of private companies for multiple reasons. NASA's been doing this for decades now. They have a lot more like proprietary and internal and like organizational knowledge that these new private companies don't. And they also, because they're giving the appropriate funding to these larger projects, they are funding projects that I think might be out of the reach of, that maybe might be out of the reach financially, or maybe if they are in the reach financially of some of the private companies, they're not in the interest of some of these private companies. These private companies are trying to turn a profit. They're trying to eventually do something that's going to make them more money. And NASA's work is really more about knowledge. and less about profit, because NASA's not trying to make money. They can send a mission to Venus just because they want to know more about Venus. They don't need to justify it by saying, well, it'll make us money. Yeah, if that makes sense.
It does make sense. And I think it's a crucial difference, exploration for exploration's sake. How many people, just an estimate, how many people in total would you think are working on the Perseverance project worldwide and directly involved in responding to the data and doing all the tests like you're doing? Is it most of the funding then coming from NASA, or is it coming from these different worldwide institutions and local higher ed institutions?
Most of the funding is coming from NASA for these. I'm sorry, what was the first part of your question again?
Do you have any rough estimate on the thousands of people working on it?
I don't. I would say on the Mastcam-Z team,
sure,
I'd say just that one singular instrument team is at least 100 people, if not more. There's the main scientists that work on it, and there's a handful of them, probably a dozen. And then all of them have graduate students and undergraduate students below them. And so each of those dozen people could have another 10, 20 people behind them. So it's a little bit hard to estimate. But like I said, that's one instrument team for the entire rover. If we start looking at the entire rover all over, each instrument team has a similar thing where there's between half a dozen and a dozen main scientists who then each have their own team of people working on it. So it's a very, very collaborative. It's lots and lots of people. I don't know that I have a good estimate, but it's a lot.
That's great. So of that team, you're mentioning they have the graduate students and they have the undergraduate students. If there's any undergraduate students right now, or even high school students listening to this that are like, oh wait, I want to change my major to do what you're doing, what classes would you recommend them taking to find out what area of expertise within this large Mars mission they would be best at, and to be able to get involved in this kind of work?
Great question. So kind of the starting points are going to be getting even just introductory geology out of the way. Even our physics students they have physics majors, they will even take outside of their major, they'll take some introductory geology classes. The kind of more higher level geology classes, you're going to want to do something like you're going to want to do sedimentology, maybe sedimentology and stratigraphy, maybe a volcanology course. Melissa teaches a class called remote sensing, and that's a lot of how we study other planets is through a whole bunch of types of remote sensing. So having that kind of background is really useful. And then any sort of like astronomy, astrophysics, that kind of stuff, if you're more on the physics side of things, is gonna help you out in getting here.
Great. Wish I knew that a few years ago, maybe. That's extraordinarily helpful. What about for little kids hearing this who are wanting to, be finding out as much as they can about NASA and science? Do you have any advice for them?
I would just say stick with it. That passion can take you a very long ways. And that's how a lot of folks that do this work started out as kids who were like, wow, this is really cool. You're paying attention in your classes, especially when it's related to the same kind of stuff I was talking about before. If there is a geology option, something like that is useful. If there is an astronomy option, that's really useful. Keep don't let anybody talk you out of that curiosity that you have as a child. That's my advice.
I love that. I think it applies to a lot more than just this. To get back to the specifics for a moment, we only have about 8 minutes left. You mentioned that the rover is taking samples and storing the samples and deposit them, that eventually 10 years from now, there'll be a ship that brings them back to Earth. How? I'm sorry I don't have a more specific on that, but how?
Yeah, that's a great question. So one of the things that's really amazing about NASA is that they start planning for things before they know exactly how they're going to do that, because these missions take so long to plan. If you're like, that technology's 3-5 years out, they plan on having that, they put the effort into making it happen now so that they can have it for their 10-year goal. So I was mentioning earlier, like SpaceX with their reusable rockets, something like that. That is the type of technology that's going to probably be applied to this sample return mission. We're going to need a rocket that can land on the surface and then also get us back into orbit.
Well, I can't wait to be able to have you back in 8 years and hear about how on Earth that is getting done, because that blows my mind to be able to relaunch something from Mars. Are there any differences between our current mission and the kind of technology and ethos or anything that we're doing through NASA versus what we know about of the Chinese mission?
We don't know a lot about the Chinese mission. I think they've released some general goals. I'm not super aware of exactly what they are, but they have been pretty close-lipped. We've seen a few images. We've seen, we got confirmation that it got successfully landed, was able to get off its landing, out of its landing vehicle. But we don't know a ton at this point. And that said, like, Perseverance is really transparent, but we still don't have, we're releasing all of the little things, but like we don't really have much either that in terms of like, we can't say with anything with certain yet. All we can say is this is how we're going to go answer the questions that we came here to ask. And so the first while that a rover is on the surface, it's doing systems checks. It's just looking around and trying to get its bearings. And so I don't think they probably haven't discovered anything, amazing in the first couple of months that it's been there. It's probably just been doing the same kind of things that Perseverance did in its first couple of months, which is making sure everything's working okay.
That makes sense. It's nice to know we're all on the same track, even if we don't have all the data. One of the reasons why I'm so excited to be able to have you here is that I'm hoping that there's some younger audience members who get inspired by this and that can see you as an idol in their community to be able to make this difference. And I'm wondering if there's any idols that you've had in the space exploration process that maybe you've gotten to meet or that you want to, or that you've been looking up to through this journey.
That's a great question. I have honestly, like Melissa, our advisor here at the Mars Lab, has just been like someone that's really phenomenal to work with. She's a wonderful advisor and a great scientist and just like an all-around awesome human being. And, being able to work with someone like that is really cool. Yeah, I think Melissa is my person.
I love that. It's always wonderful to be able to work with people you really respect. Mm-hmm. What other interesting, it's a little out of your scope here, but are there other interesting projects that some of your friends in the geologies or physics have been working on at Western that you think we should be aware of, that you want to plug for them briefly?
Ooh, let's see. I know that there are, there's someone who was studying change in glacier volume on Mount Baker, which is very relevant. She's a skier, so that makes sense. A friend of mine is working on a project that was related to like prospecting for geothermal energy in Alaska. Folks are trying to date various features on Earth using like magnetics, like magnetic orientation, and using whether the like where the poles are at various points in Earth's history to try and determine when those were deposited or when they crystallized. Let's see, what else are folks working on right now? There was someone that did a really cool project where they were looking at levels of pollution by looking at the magnetic particles, the like concentration of magnetic particles on leaves from trees, just as a way to do like cheap pollution monitoring.
That blows my mind. That utterly blows my mind. Concentration of magnetic particles on leaves is not something that I thought we would be able to talk about today. And I know people have dropped in the chat renewable energy projects and solar powered windows or solar powered generating windows for homes and cars. It's so wonderful that you are all working on this. I think we only have time for about one last question. And I was hoping if you had any final words of inspiration for people who are wanting to follow this, wanting to follow more about what the Mars Lab is doing, regardless of their age, or if they're younger, get more involved, or about why this is important that you wanted to leave us with.
Keep it up, keep the interest up, keep the enthusiasm up. You're always welcome to reach out and ask us questions. Like I've talked about the Instagram account. I do a series called Frequently Asked Question Fridays. Ask me a question. We love to hear from you. Yeah.
Wonderful. Thank you. Well, we love to hear from you too. I think Chris is back.
Yeah, Elijah, thank you so much for running those questions. You're really good at this, man. I think you found yourself a gig.
Oh, you too, Chris. Thank you.
Kristiana, thank you. Thank you so much, Kristiana, for making yourself available today. Of course, I'm biased as an alum of Western and somebody who works at Western, but I think that we're extremely fortunate to have Western in our community, allowing us to have experts like you at our fingertips to inspire us and enlighten us. So thank you so much. Really do appreciate it. I also want to remind everyone, thanks for our sponsors for supporting City Club, and also a reminder to all of you that our next City Club will be on August 25th. It will be an online forum featuring the candidates running for the 3 port commissioner positions. There you have it. Have a great day, everyone.